I would like to introduce someone brilliant. If you're serious about data science, she's someone you should follow on Twitter. By day, she leads a team of data scientists at Hearst, and by night, she organizes the economics and big data meetup here in New York City. She's transitioned from Wall Street to tech at one of New York's and the world's biggest media companies, and today she's going to deliver a talk on deep learning. Let's welcome Rahel Jhirad, Director of Data Science, to the stage.
Wow. What a generous introduction. Thank you so much for coming. So I'll talk a little bit about what we do at Hearst, a little bit about myself. I direct data science at Hearst. It's an incredible company to work in. I work with the digital newspapers, magazines, and TV, applying machine learning and then specifically deep learning. I've been working with the scalable machine learning since 2011, and before that I worked on Wall Street. I'm a proud graduate of Barnard, so it's good to be back here. We worked with Professor Kyung-Hun Cho. Unfortunately, he couldn't make it today. He is not well. But he's one of the people, when I met him, I actually didn't know what he was talking about. He was that smart. He is a pioneer in machine learning and deep learning, and in specifically sequence-to-sequence models that are used in machine translation and speech recognition. And so working with him was a privilege and in some way very an innovative mix to looking at data that we have at Hearst, which is really pretty various, which includes millions of articles, millions of images, and probably 45,000 hours of videos. So Hearst is made up of 300 businesses, magazines, newspapers, entertainment, business media, ventures, and broadcasting. I primarily work with magazines, newspapers, and broadcasting and that data. So what is machine learning at Hearst? We have a data lake, which includes all our content, the ads data that we have, audience data, on-site, so people come visit Cosmo.com or L.com, where they can read about the articles that we publish on Facebook and Twitter and so forth. So each of these things have machine learning applications that we help to help editorial. So for example, when an article comes out in L, how do we resyndicate that? Should we resyndicate that to Cosmo, article recommendations, A/B testing. So these are the traditional machine learning applications that we have at Hearst. The goal that I had with this project with Professor Cho and NYC Media Lab is to go beyond this and to work with something scalable and that's something that is innately connected to media, which is the images, the videos, and the text that compose the content of our publications. So I will describe a little bit about what is deep learning for you that don't know. So it's a branch of machine learning, but unlike machine learning, what deep learning algorithms do is they actually represent data in useful ways. So when I was an undergrad here at Barnard and I studied economics, we built models as a trader, what will forecast something. So you had to spend a lot of time thinking about what your X variables are and how you can predict Y. The power of deep learning is that the algorithm learns to look at the data and represent it in useful ways. And two areas that have shown huge success is in image recognition and in natural language processing. So here are some applications of machine learning to data, language and machine translation, summarization, gesture, understanding robotics, self-driving cars. All of these, started out with machine learning and have then been using deep learning to great success. So there are different modalities, and the project we worked on at Hearst, it combined two of them, language and vision. So language, the old way of thinking about language was parsing and what you learned in 6th grade about grammar and thinking about that to understand language. Deep learning kind of says, I don't care. I just want to look at data and the words in the context that they live in. So it's a very data-driven type of algorithm. So if you want to take a word like mom and a word like dad, the goal of machine learning and deep learning specifically is to represent that mom and dad as a vector. And once it's a vector, it's a number that you can manipulate. But what number or what vector will you represent it as? So here's an example, just sort of to make it a little bit more concrete. So if we took the word Taylor Swift, Spacey, by the way, is a open source machine learning library in natural language. So if you took the word Taylor Swift, it was represented by a vector, and then you look at what vectors are closest to it. So the idea behind these word embeddings is to represent words based on a context. Here, Spacey looked at Reddit to build the model. In vision, it used to be the case that when you wanted to understand what's in an image, you would handcraft all these very complicated edge detection mechanisms, and they're still very powerful. Huge amount of work went into it. But is this scalable? At Hearst, we have millions of articles, and every article has an image. So I don't want to be handcrafting, is this a person, or is this a car, or is this a horse? So what happened in the last 5 years has been GPU, lots of data, and essentially image recognition is sort of, many people say computer sort of, solved. It's probably not solved, but essentially what you can do is look at, this is what the sort of the guts of a deep learning network trained on images. So you see the edges. Those edges are things that the machine has figured out. So what human beings sort of tried to handcraft, all of that's gone, and now the machine can tell you what are the low-level features and sort of bigger, other features. So it composes a representation of the data. And that's why it's called deep, not because it's deep, but it's because there are many layers of abstractions that it's making use of in trying to say, okay, is this a car or not a car? So if you want to play with a machine learning, a deep learning network, this is one that's tensor, it's called TensorFlow. So what are the things that it can do? It can take an image and tell you that there's a cat in it. You can build models to segment the image and localize, the point of interest. So why is this useful at Hearst? L, for example, lots of different types of subjects that we concern ourselves with. If I look at, and from a text point of view, and then we've got car and driver, road and track, delish. We have magazines in foreign countries, Marie Claire in China. So the language and text is very rich, and the images were rich. This little graphic is 500 images I was playing with just the other day from L. So you can sort of look at it and get down to the pixel. So we're basically manipulating millions and millions of pixels across all these different properties at Hearst. So some of the applications, brands. Hearst has lots of fashion-oriented properties. How would I be able to sort of detect a brand? I came across this image, I'm like, wow, that's a beautiful bag. What is it? It was a couple of years ago, and I wasn't working at Hearst, so I wasn't so knowledgeable. Now I probably know more quickly, but it is. So in the demo this afternoon, I will show you how we basically able to detect what it is. I looked at all the images across Hearst. So here's our newspapers. We own 30 newspapers, and you can see that the machine learning mechanism of deep learning is taking the embeddings of these images and showing you, what's closer and what's not closer. So what we did with Professor Cho is look at the relationship between text and image, and can we translate that vector of text to image? So essentially saying now that, and we built a model over the summer that would allow us to input data, like put an article, and then get the suggested images of the article, or put a word, and it would basically bring out the images. So essentially what we're doing is not using any tags at all to help the editors retrieve images that are sort of relevant to that text. And the goals like translation, take these words, translate them to images. Maybe there's one image suggested, two images suggested, or take an image, well, here's a summer dress, and basically be able to take that summer dress and say, what context would this dress be more useful in? So it could be a wedding dress, it also could be just a simple white summer dress. So I think what's innovative and sort of cool about what we're doing, and very much influenced by Professor Cho, is the notion of we're taking a sequence of words and mapping it to a sequence of images. So that's our team. Thank you for listening.